Hey class, how are you? Here we are, just making sure we're on. That should hopefully clear it. All right, so today our lesson is 5.2, graphs of polynomial functions. Today we're going to focus on point symmetry, line symmetry, and then we'll talk about finite differences, and that's like your first or second differences. So we're going to put that into polynomials and how it applies to this unit. Okay, two of these graphs have point symmetry and the other two have line symmetry. Line symmetry is probably more common when you think of quadratics and you know the axis of symmetry. The axis is actually a line. Okay, so if I take a ruler, make a nice big straight one, okay, and as I move it across these, I should be able to see some symmetry. So if I go if I go across here, oh, I see, hey, that's a line symmetry. That one doesn't do line symmetry, and that one does a line symmetry. So the two ones that are line symmetries are this one. I'll go line S for symmetry, and this is line S for symmetry. The other one, which is a point symmetry. So what you do is it's about a rotation. So I'll start with this last one because it's probably easier to see that if I put a dot right here and I rotate this 180 degrees, it's going to give me the exact same, like through the rotation, it's going to give me a point symmetry. Likewise with the second one here, if I put a dot right here, I take the first one and I swing it 180, then you will notice that, hey, it's a point symmetry. Likewise, ladies and gentlemen, you can also start with this one and bring it this way, or you could start with this one and bring it this way. Doesn't matter which direction you go, as long as you rotate it around a point. So let's look at these definitions here. So a point symmetry means that the graph can be rotated 180 degrees about a point, and it doesn't have to be on the origin, and coincide with the other part of the graph. So for example, here my rotation point or my point symmetry is about 0, 0. Okay, that's the point that it is. For line symmetry, it's the line, and let me just move this one down, hopefully. Okay. And here, this is going to be approximately x equals 1.5 or 3 over 2. And this is the line symmetry. Okay? And line symmetry means the graph is reflected in a vertical line where y equals a. Okay? And when we take a look at point symmetry, hopefully you can identify that point. Sometimes it's difficult based on point xy. All right. Let's keep moving along here. Finite differences. And again, this is something like first or second differences. Okay? As we take finite differences, we find that a constant value we get has the same sign as the leading coefficient. So that can help us tell us if it's positive or negative, depending on the sign of your first differences or second differences or fifth differences where your values are all the same. Okay, how many columns of differences, so first, second, third, we take is the degree. I apologize, that's kind of scratching it out. So let me grab the highlighter for that. Okay, so let me just back up for a second, please. Grab a highlighter. Okay, so we were talking about how many columns we take is the degree, and we also talked about the same sign is the leading coefficient. All right, let's take a look at this example here, ladies and gentlemen. We have a table of values, and we're not sure what type of relationship this is. So the first thing we're going to do is do what's called first differences. So grab your calculators, and we'll do what's called the first differences. Okay? So I start at the bottom, you do the lower, subtract the upper. For those who forget, I'm going to write that down. Lower, subtract, upper value. Okay, so plug these in your calculator, and you're going to get 1,107, 525, 195, 45, 3, negative 3, negative 45, negative 195, and negative 525. So if the first differences were the same, that would tell us it's linear. It's not linear, so we would go on and do the second differences. Okay, so second differences. Start at the bottom. So your second differences: 582, 330, 150, 42, 6. Trust me, I can't do this in my head, guys. 42, 150, and 330. I've used a calculator and then got the answers and put them on a sheet of paper. All right, so if the second difference is the same, you know it's quadratic. They're not the same, but we're going to keep going. So we're going to do what's called the third differences. So right, I made those arrows a little. Let me erase those and do that a little better. Okay, doing the third differences. So we got 252, 180, 108, 36, negative 36, negative 108, and negative 180. So the third difference means that it's not cubic. Okay, so we're going to go to the fourth difference. And I know this takes a lot of work, but we'll see how close we're going to get here. So fourth difference. When I plug these in, I have 72, 72. Aha, I see a pattern. Okay, so since it's 72, that means that when we have the fourth difference, that means that the lead coefficient has to be x to the fourth. And we call that a quartic. Okay? If we had first differences the same in the third column, we would call that cubic. So cubic. Example of cubic. Oh boy, let's try that spelling again, Miss R. So cubic is going to be something like x to the third. Quadratic, you know, is x squared. So quadratic would be x squared. And linear, if you had something linear, just be x. Okay? And just to show you what this actual table's from, it's y equals 3x to the fourth. Okay? Notice, ladies and gentlemen, that in front of 72, the sign is positive. That tells me that the lead coefficient also has to be positive. Okay? So this tells us two things. One, that the lead coefficient, I'm going to use short form there, is positive. Oh, maybe I'll just finish writing it out. Okay? Okay? And the second thing it tells us is the degree. Okay? So degree equals 4. So we're looking for x to the fourth. Okay? All right. Let's try another example. Example 2. If a constant value of 5 shows up in the third time we take the differences, then we have a what type of function? That's going to be cubic. Okay, and the leading coefficient is positive. All right, so there's a quick lesson today, folks. Here's your homework, page 87 to 89, numbers 7, 9, 11, 13, and 15. Have a great day. And of course, see me if you need any help. Goodbye. Bye.